Welcome to this explainer. I am absolutely thrilled you're here. Look, today we have a really exciting goal. We are going to completely demystify the underlying technology that is powering this massive AI boom we're living through. We hear the buzzwords everywhere, right? But how do these systems actually work behind the curtain? Well, we're going to break it all down step by step and journey directly into the engine room of modern artificial intelligence.
Okay, let's dive into this. Here's our roadmap. 1. Meet generative AI. 2. Inside large language models. 3. Training the AI engine. 4. The rise of AI agents. And finally, 5. Challenges, risks, and governance.
So, let's start with the most fundamental question. What exactly is generative AI? I mean, it's the phrase on literally every company's homepage right now. But to really grasp its power, we kind of need to strip away the marketing hype and look at the actual foundation.
At its core, generative AI refers to deep learning models that autonomously create original text, images, video, or code in response to our prompts. And the absolutely crucial phrase here is leveraging learned data patterns. These systems, they're not just pulling memorized facts from some giant database. They're using algorithms that simulate how the human brain learns to encode deep statistical relationships from massive datasets. Then, they use those patterns to generate entirely new, highly relevant content.
Section 1. Meet Generative AI.
Now, what we're seeing today isn't some overnight magic trick. Actually, way back in 1964, the Eliza chatbot used simple pattern-matching scripts to simulate conversation. Fast forward 50 years to 2014, and things like GANs and diffusion models started revolutionizing image generation. But 2017, that was the true watershed moment. That's when researchers introduced the transformer architecture. That one specific breakthrough basically ignited the modern era of generative pre-training, paving the way for the massive 2022 launch of ChatGPT.
You can think of these models like different engines built for totally different tasks. VAEs compress and decode data. GANs literally pit two neural networks against each other to forge incredibly realistic images. Diffusion models, which is the tech behind stuff like DALL-E, iteratively clear away random noise to reveal highly controlled art. But the absolute heavyweights driving today's advanced text generation, those are transformers. They use what are called attention mechanisms to process huge sequences of data all at once.
Section 2. Inside large language models.
For the longest time, we relied on traditional search engines, right? Rigid algorithms that basically mapped exact keyword matches. If you searched a phrase, it blindly looked for that exact phrase. Well, large language models represent a massive evolutionary leap. Because of that transformer architecture, LLMs capture deep context, nuance, and actual reasoning. They're the very first AI systems capable of handling the messy, unstructured nature of human language at a truly massive scale.
But how do they actually write? At their core, LLMs are just giant statistical prediction machines. They repeatedly predict the next word in a sequence. When you ask a question, the AI doesn't know the final answer in advance. Instead, it breaks your prompt down, calculates the mathematical probabilities for all potential next tokens, which are basically fragments of words, and statistically guesses the most likely next piece. It does this over and over again until a coherent thought has formed.
And to make those statistical guesses accurately, you need unbelievable scale, 175 billion. To put that into perspective, if you tried to count to 175 billion out loud, it would literally take you over 5,000 years. That's the number of parameters in models like GPT-3. Parameters are essentially the internal dials, the weight variables inside the neural network. They are the encoded representations of every entity, pattern, and relationship the model learned during training. These variables configure exactly how the model processes your text.
Now, what's really fascinating is how we ground the abstract math of self-attention. Imagine an LLM reading an essay about a dog. The self-attention mechanism mathematically calculates that the word bark has a super powerful high-weight connection to the word dog, while completely ignoring its relationship to the word tree. It seamlessly tracks these relationships across huge distances in the text, allowing the model to flawlessly maintain context and generate those human-like responses.
Section 3. Training the AI engine. So how are these massive statistical prediction machines actually fueled and shaped? The training cycle happens in 3 distinct steps. Step 1 is pre-training. This is where the model absorbs terabytes of unstructured internet data. It basically reads the whole internet to learn grammar, facts, and logic. Step 2 is fine-tuning and RLHF, which stands for reinforcement learning from human feedback.
This is where humans rank the AI's outputs so it learns to align with what we actually prefer. And finally, step 3 uses RAG, or Retrieval Augmented Generation. Think of RAG as giving the AI an open book test. It lets the model access live external databases to retrieve real-time facts it wasn't originally trained on.
Why is this multi-step process so absolutely vital? Well, because step 1 only gives us a foundation model. Think of a foundation model as a brilliant but incredibly unfocused generalist. It knows a little bit about everything. By putting it through fine-tuning, we create a tailored specialist. We feed it medical journals or legal Q&As, transforming it into a highly optimized expert for enterprise use. You wouldn't want a broad generalist answering specific legal contract questions, right? You want the fine-tuned specialist.
Section 4. The Rise of AI Agents.
Generative AI is already drastically boosting how we work. In a single afternoon, it can draft complete project summaries, generate incredibly realistic concept art, debug the software code to actually run the project, and even generate synthetic molecular data for scientific simulations. It's a massive accelerator for creativity and massively reduces digital labor. But here is the crucial point. We are currently living through a massive evolutionary leap, the shift from chatbots to AI agents. A standard generative AI chatbot can look at your schedule and suggest the best time to climb Mount Everest. Impressive? For sure, but passive. An AI agent, on the other hand, exhibits true autonomy. It takes that suggestion, securely connects to travel APIs, and actually books your flights and hotels without you lifting a single finger. We're moving from AI that just generates text to agentic AI that makes complex decisions and takes action.
Section 5. Challenges, Risks, and Governance.
Of course, with autonomous agents entering the real world, we face some very real hurdles. First up, hallucinations. Because these models are probabilistic guessers, they can confidently generate information that is entirely false. Second is bias, where raw internet training data teaches the AI to amplify harmful societal stereotypes. Third, deepfakes, the malicious manipulation of audio and video for fraud or misinformation. And finally, the black box dilemma. The reality that sometimes, even the engineers who built them don't fully understand exactly how these neural networks reach their conclusions.
So the vital solution to these vulnerabilities is AI governance. This involves strict processes, guardrails, and evaluation benchmarks needed to keep AI safe. Practitioners are relying really heavily on red teaming, basically acting as ethical hackers to intentionally try and break the model to expose its weaknesses. It's all about rigorous testing to ensure accuracy, fairness, and transparency before any of these models are deployed into the wild.
And that brings us full circle. We've journeyed from the basic definitions of deep learning all the way through the self-attention of transformers to a near future where AI acts autonomously on our behalf. Which really leaves us with the defining question of our time. How will society balance the immense, literally world-changing power of agentic AI with the human guardrails we absolutely need to keep it safe? Thank you so much for joining me on this explainer. Keep learning and keep asking those great questions.